All right. Hello, everybody. Welcome back in. My name is Michael. Hope you're having a wonderful day so far. Let me button this up. I'm showing too much chest here. Hope you're having a wonderful day so far. We're going to be back, jumping back into C programming a modern approach today, and continuing on with our exercises here. Yesterday, or last time we left off, we finished off on chapter 12, exercise 10. And so that's what we're going to be tackling for today. Hopefully we can continue on and finish up these exercises today and get on to reading chapter 13. I would like to finish the exercises and read chapter 13 today. That's my goal. I want to be productive. Whether it takes us a long time, that's okay. I've got nothing else to do today but this, and I don't know. I kind of want to, while some people get in here, have a little bit of a discussion. I've just been honestly feeling a little discouraged lately. I've been kind of falling victim to the AI video doom scrolls. Just hearing the doomerism of, AI and how it's better than you and what's the point, right? Anywho, trying my best to block out those thoughts and just focus on programming and learning and having fun. But obviously, I'm human just like anybody else. So it's pretty hard to at times. And I bet you a lot of other people feel that way as well. So, some people might feel some relief that other people are experiencing the same thoughts. Or if you're not, you think I'm done, let me know and maybe provide your insight. Anywho, um, hope you're having a good day today. This should be a fun one. Um, yeah, I'm not really going to put too much pressure on it. Let's just go ahead and dive right in and see what we can do here, right? Let's see. Okay. Hey, Chill Clark. Thanks for coming in, dude. Appreciate you being here. Kappa says, I jumped to C++ after reading 10 chapters of this C book that you're reading. As far as I could gather online, C++ has more job avenues. Once I secured a job, I can always learn C again. Interesting take, Kappa. How have you been liking learning C++ compared to um, where we've gotten so far in the book? We're up to chapter 12 in the book. Honestly, I don't really feel, though, that I can really make anything at the moment. I mean, we did make a small C project, just like doing some basic printing in the terminal for creating like a time clock using some analog kind of ASCII kind of whatever number representations. That was a fun little like hour or two that we spent building that. But other than that, I really don't feel that I'm capable of actually like doing anything in C other than just writing basic functions that I can write in Python, right? So I'm hoping that we can, as we dive deeper into the book, unlock a little bit more insight into the computer and how it interacts with C, and maybe we can figure out that's really where my bridge, the gaps and the bridge are, is where I'm trying to bridge the gaps is I just don't know where to apply a lot of these more lower level concepts, as I just don't know, you know, I just don't know. Anywho, but if you guys missed the little chat we had at the beginning of the stream, now we have some people in here. I'll kind of go back and say it again. I've been kind of a little bit on the depressed side. I don't know if that's the right way to say it, but in terms of like programming, like now that we finished some of our projects and things like that, like Polywhirl and whatnot, I've been like kind of sucked into the doomerism scrolls of like AI doom and like it being better than you. So like it's what's the point? And it's hard, guys. Like I know what I preach on here, just learn and have fun, but even me, like I fall victim to it as well, just like getting sucked into those algorithms of doomerism, AI, BS. Like it's just so uh It's just such a confusing time, and you have half of people telling you one thing and half of another group telling you another thing, and there's just no truth. There's just no truth, and it's really frustrating as like a consumer, someone that's trying to like navigate the fields, and like I bet you a lot of other people probably feel this way, right? Because it's just it I have a job, right? And like, you know, I'm not super like satisfied in it in terms of, I'm not building anything like that I want to build, or I'm kind of just doing administrative equipment management and for a laboratory. And but the thing is you can't really whine right now. You don't have any justification to complain, because there is there is worse circumstances out there. But the thing is that I've been telling myself for like, for 4 years now, like, oh, the job market, it'll turn. It's gonna turn. It's gonna turn. It's gonna turn. That's what everybody says. It'll turn. But the reality is just starting to become more realistic to accept fate rather than have hope, right? And it's just like, I don't know, like, yeah, people are losing energy for hope, and it's really tough. Like, I, I, I don't even have the right words to kind of articulate the feelings. And even I'm somewhat of a kind of a smarter guy-ish sometimes, not in some areas for sure, but some areas I don't know. And I just kind of struggle to really understand like what's really going on, and I can't even really deduce it at times, and just fall victim to these doom scrolls. Anyways, let's see what everybody else thinks. I still can't get you much. I still can't get much of how arrays can be more useful than using lists. Yeah, it's interesting. Well, we don't really have lists in this language. We have arrays, which are lists are just an abstraction built upon arrays, and it is lists are kind of like a technology that is like built, programmed into the in on top of arrays for how to maybe be more user friendly to an average person, so you don't have to manage memory or things like that. So um, now I think for general purposes, that's why lists. That's what might be why you're feeling that way. Is that lists? That's why they were built. Is because they were to be useful like that. So maybe you're in a similar circumstance as me, user 1125. Is that I too don't really have any circumstances personally where I would want to use an array over a list, because I haven't really come across any in the real world, and that's just because I'm probably not there yet. And we're trying to get there, but navigating to those points is pretty confusing because I don't really know how to get there. And we're trying to just figure it out, dude. Oh, it's so hard. It's so easy just to sit here and be like, where do I go? And then just walk away and give up. So you got to just keep going little bit by little bit like that. What does the Japanese say? Anyways, let's keep going on some chats. I remember joining in your second session of C, and now I'm returning to it. I'm in this array section. It's really fun. Nice, Chill. Everything carries over from C, and it has some more things. My main goal is to move to GPU programming. That's cool, Kappa. Thanks, Chill. Thanks for the kind words. Building stuff using C, I share the same sentiment. So I jumped ahead to CPP first because I don't want to stay into tutorial hell. So we're building real stuff. Okay. Let's keep rolling. Okay, today we are on number 10. We got to keep going. All right. Modify the find middle function of section 11.5 so that it uses pointer arithmetic to calculate the return value. Okay, 11.5. We need to find this function. Let's go back to a chapter 11.5. We need max. Is it example 11.5 or? Ah, crap. What did it say? find middle function of 11.5. Find middle. Okay, here's 11.4. Max min decompose. This is 11.4. No, 11.5 max. Oh, here it is. It's like 2 lines. Okay, so we're going to modify this function, find middle. Let me take a picture of it. And then let's go back to the question. I hate how it does this. I wish it would put, like, I don't like going back to the pages. It's pretty annoying. Oh, come on. I'm struggling, you guys. Sorry. Modify the find middle function to use pointer arithmetic to return value. Okay. So let's do this one here. Come on, scroll over. This is pretty annoying. Okay. So this function has int find middle, which returns an integer pointer to the middle, right? So it has int find middle, right, which is it returns an integer pointer. It takes in an integer array A, and it takes in an int n, which we're assuming is the size of the array A. And then the original function returns, right, the address, right, because we're returning a pointer, return the address of array index n divided by 2. Okay. So we're trying to modify this to use pointer arithmetic to calculate the return value. Pointer arithmetic to calculate the return value. Use pointer arithmetic to calculate the return value of just this line here. Right? Huh. How would you, with pointer arithmetic, you add integers to pointers. We're given an array A. Okay, let's return the address of A plus n over 2. I think that's the same thing. Right, we can add n over n divided by 2 to A, which is the starter or the pointer to the array, and do the address of that value in memory, and that's the middle of this array pointer. I think we got it. What do you guys think? What do you guys think? Okay, so if we go int main void, and we have a integer array of size 5, or let's have I don't think we can do this. Call print star print f %d to the value at find middle dereference for a n. Turn 0. Okay, let's CD chapter 12. CD chapter 12 exercises. CD chapter 12 exercise 10. We're going to go GCC-0 like that, including header. Oop. Yeah, we can't do this. It's kind of annoying. Oh, here? Expected closing parenthesis. Oh, whoops, sorry. Cannot take the address of type int. Of an R value of type int star. Oh, it already is a pointer. Okay, it already is a pointer. Now we get 2. Boom. Right. Okay. Okay, cool. That's number 10. Good job, guys. What's the name of this book? This is C Programming: A Modern Approach. What's the point of using GCC versus make for compiling? I'm really not sure. We haven't learned much about make, but isn't make more like a file that has your preprocess or your compiler flags and directives kind of built into it already, and then you run that make file. So rather than having to rerun like the commands over and over again, it's just like maybe a faster way. I'm not exactly sure. What do you guys think? Anybody know? All right, we deserve a drink after that one. Cool. That was number 10. Nice. I think that's good. Let's try it with a bigger array here. Three. So that with an even sized array, it'll do this one because there is no. You kind of have to you have to preference. Some middle functions either will do one less than or that one. But in this case, they just do the floor, so we'll leave it at that. Okay. Let's do number 11. Let's move on, you guys. If you guys are doing these with me, let me know. How do we feel about that one? Okay. Exercise 11. Here we go. All right, exercise 11. We're going to modify the find largest function so that it uses pointer arithmetic, not subscripting to visit array elements. Okay, we have a find largest function. Where is that? Didn't tell us a... It did not, I mean, we can easily make one, but it didn't tell us one to reference. Okay, let's just do it. Let's include the standard io.h. Let's int main. If you guys aren't subscribed, make sure you subscribe. I stream almost every single day, me teaching myself computer programming from scratch. If you guys would like the stream on this Sunday, welcome. Let me know what you're working on, and if you're doing these problems with me on the side, then let's do these together and practice. Welcome. Okay, so int main void here. We're going to find largest function that uses pointer arithmetic. Okay, so let's return a pointer for find largest, an integer pointer, fint find largest. And then what we're going to do is we're going to give it an array, and we're going to give it an integer n. Okay. So we're going to use array subscripting. So we're going to do while, or no, so we can use a for. We could use a while loop because it's going to be larger places in memory because it's sequential. But we can use for, and then we don't need to specify a variable because we already have a pointer. We can say, or I guess we would need to provide some sort of value. No, but we don't want to track an integer, right? We don't want to use an integer. We can just use a pointer and increase the pointer. But we can't increase on like an array, right? Because if you say like while a less than n here, that doesn't work. Right, because yeah, a is a pointer to the start of the array, but we can't increase on a because a actually represents an array. Let me go back and look at some of my previous functions here. Okay, so you do declare a pointer to the start of the array. And then n is a pointer to a plus o, got you. So the end of the array is actually a pointer of a plus n. And then we can establish int star p is equal to array a. And then we can go p plus plus. Right. And then what we can have is an integer LRG largest I guess that we can actually make two let's actually make, yeah, because we actually need something to house. P increases through. This could equal actually to the array start. We can make this be a pointer. Right, the largest is just the start of the array, and this is array plus 1. An expression here, array plus 1. While a is less than the, while p is less than the array plus n, p plus plus, and then we say if the value at largest, or if the value at p is greater than the value at largest, then what we're going to do is set largest equal to p, right? And then move on. And at the end of this, we're going to return largest, which is an address, right? So if we have an integer array a, which is like 0, 1, 2, 3, 4, let's do like 0, 4, 3, 5, 7. Let's make the largest not be the last number. And we have int n, which equals to 5. We feed printf to a value %d and give it to the largest, which would be, we want to call find largest and return the dereference of find largest, which would be for array a and n. Something like this. Oh, whoops. It's not Python. Sorry, guys. You guys are probably mad at me. And I'll say n is equal to the size of a over the size of a index of 0. And then we have to probably just wrap those in. Expected. Oh yeah. Let's go. Woo! Woo! That's what I'm talking about. Yes! Man, we good. Look at us, C programmer, baby. C programmer. Let's think here. Right, because we are doing a size of, what if the array isn't there? Right. um, So if we say p is less than x, well, pointer. Well, we know that the pointer is 1 past, so we can't go out of the bounds. So we say if n so actually the size of the array A is 0. So if the size of the array, if the size of this guy is 0, right, then we don't even need to do this one because, but does the array have size despite having no values in there? Does it have some sort of taking up space? No, I think it's just the total amount of integers, because that would make sense if it was divided by the amount of integers within, right? So if we did so this assumes that it gives you these two values, right? So if n in this case that we give you is equal to 0, then we're going to return just largest here right off the jump. We can say n is not equal to 0, or is actually if n is greater than 0. We'll do this. Well, if it's 1, we don't want to do, actually if it's greater than 1, then we will go ahead and run the for loop. Right? If it's greater than 1, we'll run the for loop. Else we'll just return largest no matter what. But if n is 0 in this case, what would you check for that? We never really have to go over that in the book yet. Let's make sure that this still works here. Non-void function, not return a value. Control. Okay, interesting. Oh, whoops, sorry. You do this for loop. Return largest. Still 5. Okay. C cannot have a 0-length array. Okay, so then if that's not the case, then well, you're also feeding n in predeterminately here. But if n is 1 here, then we return largest right off the jump, which I think makes sense, right? If it's greater than 1, then we're going to do this. If it is 1, you return large. If it's 0, you won't even get past this part here. So, whatever. All right, moving on. Number 12. 12. Let's keep going. Write the following function. Void, find two largest const integer, pointer A, and integer n, int star largest and int star second largest. A points to an array of length n. The function searches the array for the largest and second largest element, storing them in the values where it was pointed. Okay. So let's include the standard io.h. Let's go. Hey, what's going on, engineer? Mohammed, appreciate you being here. Welcome. If you guys are new here, subscribe. Welcome. I'm trying to learn and just stay afloat and keep sharp. I don't know. This time, we're in very confusing times, you guys. Sap Tree, thanks for the comment. Oh, hold on. I got some comments here I missed. Not sure. Watched CS50C lecture today, and they were running make file name that makes and creates the binary. Yeah, they have like their own kind of makefile setup, I think, in their own in their internals that kind of abstract out the use of kind of calling the compiler because I think they didn't want to use that for fresh people getting into programming. It's a lot to kind of take in, but we haven't really gotten into makefiles and stuff yet either. So, do you recommend any sources for backend programming? I know HTML, CSS, JS, and React. Trying to learn Fast API now. Yeah, Muna, check out uh, I would really take a stab at looking at Corey Schaefer. Corey Schaefer's programming tutorials on Fast API. He just uploaded a whole, I think, like 18-part series or something like that. The videos are about 5 to 10 minutes each. It's really good. Way put it on like 1.5 and just kind of cruise through it. Get like a good overview. He builds a full backend app, and then uses front end using Jinja syntax. So it's pretty Python heavy for its use of front end or web development. So go check that out, and it's a great way to get some exposure into it. But there's just a lot. I totally feel you. Curious how you're finding memory management. It's going pretty well. We haven't really had to actually get there yet. We're just kind of getting into pointers now. We haven't had to free memory yet from the heap, as we are mainly dealing with stack variables things on the stack right now, as we're creating functions and variables, and arrays and whatnot. Or what do arrays? I think right. It would be we have to physically create memory on the heap and then deallocate it. Um, if I remember correctly, I don't know why I go through stack versus heap stuff probably like once every 2 weeks, but then it always seems to like fade. So frustrating. Okay, let's keep rolling. Number 12. Right in this function here. Okay. So this is going to return no value, right? Because it's going to set the input pointers, the parameter pointers to the values. So we're going to have const int star a, int n, int star largest, and int star second largest. Okay. This is going to say well, we need to set the pointers to something or they're going to be garbage values. So we need to set them to the first and second values in the array. We need to do a comparison of them. So if n is less than 1, we're going to return like it doesn't work. Or something. I'm not sure what we return if it doesn't work, because you have to have two values in the array. So what we can do is we would set the value of or largest is going to be equal to array A, and second largest is going to be equal to array of A plus 1, right? We're going to need to do a check here, right, before we actually iterate forward. Because what if it's just the size of 2? You don't actually move forward and do a check. So we'd have to do a check here. So say if second largest greater than largest, we're going to swap variables. We'll call a function swap. We're going to swap I don't really want to do that because I don't know. Let's just do it here. Let's say int temp. This is actually a pointer. So int star temp is equal to we're overwriting the largest value, so we need to save it. Well, actually, we don't need to do this. We can just flip-flop the pointers. So largest equals to array plus 1, and second largest equals to array. And this would just return here. Now, in the case where we can loop and keep going, right, in the case of the loop where we keep going, we would say while the thing is we need to keep track of while either one of them doesn't go beyond, right? But we need a pointer. So for int star p equals to array of a plus no, we wouldn't return here though. So we do the swap. If second largest is greater than largest, then the largest is equal to a plus 1, and second largest goes to the start of the array. So we just swap the second largest 2, now it becomes largest. But the thing is do we start a pointer on so if n is, at this point, if n, what if I say if n is less than 2 here, return. This might be kind of annoying, but so now you know you have a greater than, so p is a plus 2. We're wanting to go while p is less than n, p plus plus. Sorry, not less than n, a plus n. These are expressions. Right, if the value at p is greater than largest, then what we're going to do is largest becomes p, and then star temp equals to the largest. Int star temp becomes equal to largest. We save the value of largest. We move largest equal to, or no, we move second largest equal to largest, move largest down, and then move do we need to do that? Star p becomes the largest, which was at temp. Star p becomes the largest, which was at temp. and then we move largest down to second largest, and then save largest as whatever star P is now, which would be we don't need a temporary variable, I think. We just move largest down to second largest, and then save largest equals to P. Right? If it's greater than largest, it just pushes everything down, right? So second largest become largest, and largest now becomes P. But if we are greater than the second largest, but not greater than the largest, then we need to override second largest to P. Else if star P is greater than star second largest, right, then second largest becomes equal to P. Else if P isn't greater than, you move P forward. Okay, let's go through this. So what we have is an integer array A, an integer n, which is the size of the array, a largest pointer, and a second largest pointer. We then, right, if the array is less than two integers inside, then we know we can't even do this in first and second largest, so we return. Else we set largest equal to A, which is the pointer, right? And we set second largest equal to array plus 1, the second value in the array, because we've cleared through this conditional check, right? We check if those two values need to swap actually, and if they do, we swap them, meaning that, okay, actually the second value is largest than the first value. And then we also check if the array is only two sizes. If it's that point, then we can just return right away. We don't even need to go through here and assign P to the next step, to the third value, right? You just assign first and second to these variables, you check them, and then if this happens to be the only variables in the array, it's over. Now if we go to here, we set to the start of the, we set P, our pointer that we're going to algebraically move through the array, to A plus 2, right, the third place in the array. We then make it sure that the P doesn't go beyond the array. And so if P is greater, the value at P is greater than the value at largest, then we push largest down onto second largest and set largest equal to the value at what P is, the address of P. Else if, right, we're not bigger than largest, but we're bigger than the second largest, we override that value. And I think that that's it. So let's write a function here, int main void, and we're going to have a integer pointer, largest, second largest, n, and a. We're going to have n be equal to 5 in this case. We're going to have an integer array a equal to 0. We're going to do 1, 4, 2, 5, 3. We're going to call printf to %d and insert the value that's returned, the value, we'll say largest, second largest, okay? And then we're going to insert the value of, we're going to call the function find to largest on a n largest and second largest, and then we're going to run this and insert largest, second largest, but we're going to insert the values of these pointers. And then we're going to return 0. Okay, let's try this out. CD exercise 12, GCC-O. I'm missing a semicolon here. Error expected expression, incompatible type, pointer, Okay, so we're getting errors, expected expression here on line 11. And then on line 22 as well here. I have to put a return. Is there something? Yeah, that got rid of the errors. Segmentation fault. Segmentation fault. What does segmentation fault mean again? What does that mean again? Fault or failure condition raised by hardware with memory protection, notifying operations in the software's intended access a restricted area of memory. Huh. Anyone have any ideas? Should we print? Let's take this and put this here on each pass. Let's see what happens. Largest 4, second largest 2. Largest 5, second largest 4. Why would P be going beyond? Yeah, good point, Kappa. Values here. I don't think that solves our problem though. So largest 4, second largest 2. Largest becomes 5, second largest becomes 4. Largest becomes 5, second largest becomes 4, and then we fault. Why do we fault? Five places beyond the first start of A, and we need to be less than that. Because A is the start of the array. So 4 places beyond. So yeah, that's fine. A less than N. Um, okay. Um, I really don't know. Why are we accessing, where are we accessing P here that would go beyond? Largest is 5, second largest is 4. And then we are hitting 3 on the sauce, man. Hey AJ, maybe you can help us figure out this bug. What's going on, dude? So we start off on these twin. Largest is here, second largest is here. It swaps them, and then it puts P here. Puts second largest to here, and then prints this. Moves P here. Sets largest to this, second largest to this. Prints this. Moves P here. Prints, and then it moves P one more time. Why is it moving P one more time when P should be less than A plus N? Because if I put less than 1 here, oh, we still fault, and it doesn't print that last time. So maybe we're trying to access. Maybe that's not what we're trying. That's not the problem here. We're going to segmentation fault on finds two largest integers in an array using C here. But we are appropriately finding the two largest. N is 5, which is the size of the array. Huh. Because this isn't printing, so the bug is in our function. Now if we print f, the value at star p, and see what that is, three, and then it's segmentation fault. So it gets to this 3. Why is it continuing on? We're declaring a pointer to be equal to, we have to say that the address at the pointer has to be less than the end of the array, and we increase the address forward. If star p is greater than star address, do we need an else? I don't think we need an else. Is it not implied? Yeah, that's not it. Maybe it's already done. I'll switch to on it there, man. It breaks. Means at the end of the array, it prints what the last one is. It's test. If I print this, this does that. And if you print inside of the for loop, it doesn't matter what. Segmentation fault. What is wrong with this? Gonna go to the board here. Passing them a pointer. In C, largest and second largest are int star pointers passed by value. Assigning them to inside the function doesn't affect their pointer. Call a pointer all you need int star star. Modify from the outside. What? If n is less than 2. I already know it's not less than 2. So that. So 1, I know we have 2 in there at least. X is largest, which is the array A plus 1. Huh, I'm confused. Star. Heck? Ugh, I don't know. Let's think. So if we come to this line, we know that we have less than 2 values in the array. No, so this should be if it's less than 2, do nothing. This goes away. We know that there's 2 values in the array. If it is 2, then we know we can do this. And we'll say if it's less than 3, you return. Right then and there. You go this forward. We declare int star largest and int n. We pass in largest and second largest. Why does passing int star by value means the function assigns the largest and second largest never reaches main. The caller's pointers remain uninitialized garbage. Huh. Passing int star by value means the function assignments to largest and second largest never reach main. Int star are pointers. We pass the addresses in. Pointers. But the problem is C passes everything by value, including pointers. So when you do largest equals to A inside the function, you're changing the local copy of the pointer, not the one in main. pass its address. So I need to pass the address of each of these pointers here. No. Did we learn about any like double star BS? Think about it. I don't think so. No. Sweet. I so stupid. Oh, so integers, largest and second largest. Oh, okay. And then 5. So we're creating integers, largest and second largest, and n equals 5. And then we're putting the addresses in, receiving those as pointers. Indirection pointer requires operand int invalid. And so we can just use the value of largest and second largest here. Now largest is garbage though. And second largest is 0. Oh god. Dang it. So we have largest and second largest here. We have this. We have an array. We feed the address of largest and second largest into here. And so we're passing in pointers or addresses, integer addresses. Okay, then we're saving largest equals to the value at A. Well, these are addresses, so largest points to the value at A. Second largest points to the value at A plus 1. If second largest, the dereferencing of second largest, then we swap them. Oh, why is this so tough? Largest equals to A. the value at A is greater than the value at A. I don't know. Ah! Yeah, it's so stupid. I hate using it. It's just like, doesn't do any job explaining anything well. It just says, like, here it is. So we set largest, which is an address, equal to A. I don't know why I can't do that. I guess let's just set largest equal to the value at A, and the value at A plus 1 is second largest. But largest are pointers. Oh yeah. So this would be star largest and star second largest. So now if those are there, we'd set largest. We'd swap those values, right? Then we would use A plus 1 star A. Now, we probably need to make P const star P because it's accessing A here. A plus 2 star P, and then these have to be stars as well. So we're modifying the physics. So we're passing in addresses and then modifying those physical address spaces with the values. So we're saying, okay, take these address spaces and modify them appropriately. I get them back. Okay, now that I have a 2 in there, now I have a 5 in there, right? It's like, here, borrow my car or something, and like, you left your keys in it, or I don't know. So the largest would become the value at P, like such. Boom. There it is. Yeah, okay, so what was wrong there is we were kind of mixing up the pointer stuff, like typical. So we're passing in addresses of integers, right? So we have integers largest and second largest. We take the addresses of those values, so we're going to pass them in so we can modify those address places and fill them with some sort of integers appropriately to how the function finds. We do this and we get it. Now I don't even think we need this line here because this will automatically set P one beyond. It'll realize P is beyond and not even start this loop, so we don't even need this. Yeah. Dang. I think we're good though with this. Oh, that took way longer than it should have. Sorry, you guys. Okay. All right. 13. 13. Section 8.2 had a program fragment in it which nested two for loops initializing the array ident for use as an identity matrix. Rewrite this code using a single pointer to step through the array one element at a time. Since we won't be using row and column index variables, it won't be easy to tell where to store one. Instead, we can use the fact that the first element of the array should be 1, and the next n elements should be 0. The next element should be 1, and so forth. Since we won't be using row column, won't be easy to tell where to store 1. Instead, we can use the fact that the first element of the array should be 1 and the next n element should be 0. And the next should be 1 and so forth. These are variable to keep track of how many consecutive zeros have been stored. When it reaches the count of n, it's time to store 1. Okay. So let's go to section, let me take a picture. Let's go to section 8.2 and look for a double for loop initializing ident. Was it 8.2, 8.4? Shoot. Um, 8. A doubly nested for loop that filled an ident matrix. Here. Okay. So we're going to include the standard io.h. We're going to have int main void, and then we're going to have a function here. We're just going to do it here, I guess. So we're going to define n to be 10. Okay. We have a double ident matrix, which is n by n. We have int row and column, which you don't use. Okay. So we're now going to transition this double loop, this double for loop, nested for loop, into a single for loop. And why can we do that? Well, we learned in C that memory arrays are stored in memory in row major order. What that means is that rows are stored sequentially. So row 0, the first row in the array is stored, and then the next in line. So boom, 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 row after row after row. So every n items is a new row. And just by knowing how memory or these arrays are stored in memory in C, we can use a single loop. So we know that it's n by n, so that there's that many places in the matrix. So what I'll do is I'll say for star p int star p equals to, right, the first value in the array, which would be ident, right, the address, we're pointing to the first value in ident array, while p is less than n times n, right? That's how many values are in the array in the matrix total. So we just have to go less than n by n, right? We're going to move p forward. Okay? So what we do is we are going to say we probably should keep track of a variable such as int count equals to 0. And what we're going to do is go at the end of this array, we're going to do count plus plus. And at the beginning, we're going to say if count is equal to n, right, we're going to place Ooh. How do we know where we are in terms of P? Yeah, we don't know where we are, so we say ident key of what? Well, we know that this is P plus A. And what would this be? This would be big N less than P. Right? Whatever value we are from the start to whatever value we are from the end is equal to 1. Else ident key of P plus A, or N less than P, equals to 0. Count plus plus. In this one, we need to set count equal to 0, reset it back. And then what we can do is on each pass of the loop, we're going to print F to we're going to up at the top, we're going to print F to the value that we're going to do. Which would be the value at star P. That's if we after we set the value. And this would go with the backslash n there because it's the end of a row. And this would print no matter what. So if we run this is exercise 13. Oh, whoops. CD, exercise 13, GCC. Invalid operands to binary. Oh, yeah. And we know we're at P. Well, P is just the value in the array, actually, so we can just do P is equal to the value of the array, so we can just say the value at P is equal to 1, I think, rather than that. And actually, it's the value at P is equal to 0. Because the P is moving through the the memory spaces in ident, and so we can set the address at the value at whatever p is to the pointer. Order comparison pointer int star and int. So while it's less than a plus, or ident plus n by n. Comparison of distinct pointer, incompatible pointer type initialization. So, sorry, this will be double. And then this is warning comparison of distinct specified from int, but therefore argument is double. Hold up. So what does this say? Incompatible pointer types. Initial types initializing double star with expression of type double 10 by 10. P is equal to ident. Right, and so these are floats, right? So one is being placed at the end of the array. So what does the problem say? It says, let's go back to the problem here. Chapter 9, 10, 11, 12. Number 13. Here. That the fact that the first element of every array should be 1. Okay, so we're going to set n equal to count equal to n. If n is count is equal to n, else is 0. So that'll set the first value equal to whatever in the array. Let me stand up. My leg's falling asleep. Gotta stand up, boys. Ah, my leg's falling asleep. Okay, so we loop through the array.
Puppies? Should you know my puppies?
Okay, so I think that this potentially is doing what we wanted to do. count always increases no matter what. Count would decrease, and then count goes back to, so it's if count is equal to n, keep going. Start count at 0, place 1. So if it's n, we place it, we lower it down, we reduce n down, place it, else it's 0, and we reduce count. Now count's going to get to 0 at one point. If count is equal to 0, once the count reaches n, it's time to store 1. Okay, so count is equal to 0. If count is equal to n, we set p to 1, and we set count back to 0, and we keep increasing count forward. But what we'll do is we'll set p equal to ident plus 1, and before we do this, we set we'll take this, double p equals to ident plus 1, so star p equals to ident, star p, the value at star p is equal to 1, and then we'll increase p forward. And now we have this. So now if we print, if we do p is equal to ident, and we loop over this again and just print the values for, well, p is less than ident plus n by n, p plus plus, printf to %d, and we'll insert the value at p as such. But the thing is we don't, because we're not using row and column, so let's actually just do this. Int row equals 0, column equals 0, for row, we'll do, hold on, for int row equals to 0, while row is less than n, row plus plus, we'll loop and do for int column equals to 0, column less than n, column plus plus, we're going to printf to the value here at ident index of row, index of column, and we're going to actually print an entire row's worth of columns, we're going to print f to a backslash n. We're going to return 1, 0. So if we run this, double star p equals to ident. Comparison of distinct pointer times double star and double star. Segmentation fault. So we say the count is 0, and then we have double p is equal to the double star p equals to the start of the array. Double ident. So count is equal to 0. We have a pointer p, which is of type double, and that's pointing to the start of the array. We're going to move p forward as long as it's less than the end of the double matrix, the matrix. Warning, incompatible types initializing double star, so double pointer with the expression of type array 10 by 10. Let's get some help. Close, but your diagonal logic is off. The first element, ident 0, 0, gets set to 1 correctly, but then count never resets at the time. Diagonal elements. Oh, so count gets set. Reset count. So double ident. We set count to 1. Huh. Why would it set count to 1? So it's saying set count to 1. Right? Initialize double star p here equals to ident. Equals to star ident. Why is it star ident? star? Doesn't make any sense. Why is it star? Oh. Oh, we deref the overarching array, leaving us with a single array inside the start, which is a value technically that P points to. Okay, so we set star ident here because this is an array inside an array, right? It's arrays inside an overarching array. By dereferencing the overarching array, we get a pointer to the first array in the overarching array. Now, I know that sounds crazy, but let me pull out the whiteboard here. Right, so we have an array of arrays, right? This is what they look like, right? If you think about it, like X, Y, blah, 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 Z, B, blah, 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 A, 2, blah, 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 right? By calling star kind of gets rid of this, and we have P points to this array right here. So P points to that array, count as 1. So if we run this now, P is less than the value at ident times this. Well, no, we want to be less than the dereference of P to a single of the ident to a single pointer. There we go. And do that, we get this. So that's not what we're wanting. We're wanting 1 to be on the beginning. So are we storing 1 at the end or 1 at the beginning? Initialize. For this current value, and is 1. Yeah, okay. I think it's supposed to come at the beginning. Count to 0. But if it's equal to n, we place it. Huh. Okay. I think it's fine for the gist of the problem. Might not be placing the one in the right spot, but um, it's okay. It's kind of trivial logic at that point. But the overall idea of it is finalized. Okay. So let's keep going here. Number 14. Put the condition if. Yeah, I wasn't sure what the 8.2. I don't want to go back. I don't want to go find it, but I'm not sure what the specification is. I was assuming that it's for one at the beginning, but if it's runs out to end position, then you place the one. Then yeah, it makes sense. Okay, let's keep going. Thanks for coming in, Avercane. I think it's just you and me in here, maybe one other person. We got two people in here right now. So this is where the learning happens, and as you can see, it's kind of funny when I start streaming C stuff. The views drop off heavy, but when I stream full stack, programming, I get like 1,000 views on the stream. So I don't know. That in itself is kind of proof, you guys, that like the large majority of the market is going towards using AI full stack, trying to grind out real SaaS projects or whatever. But no one, at least from the data I'm picking up here, is that no one really wants to learn this stuff. Like no one wants to go through these practice problems and put in the time with their head down thinking about why their pointer is segment faulting on a 2 by 2 array and trying to figure that out. Like it's just very apparent the drastic attention that differences between the streams, right? So take that with what you will. Maybe that as I often like to find ways to go against trends that aren't there is very a lot of value in following momentum, right? There's if you follow like momentum for and you can ride waves and catch waves and stuff like that, but there is um, some circumstances you can find where if you go against the current, you actually kind of stand out. Now it's not always you have to kind of pick and choose pick and choose these kinds of battles that you're gonna go through or whatever, because sometimes it's not worth it to go against the current for certain things. But in certain circumstances, like I think with this is eventually you're going to get to a point where there's only going to be a select niche group of people that know these types of lower level languages and can implement them. As the tens and hundreds of thousands of people start abstracting out or obfuscating out there, like learning to AI models and whatnot. So I don't know. It's going to be an interesting, maybe like it is kind of like an investment. You do have to think about it as an investment, as um, the payoff. The world is so large, and the technologies have to spread throughout everybody, and then everybody has to consecutively realize like, oh, this isn't actually, or whatever. So it takes a lot of time, is what I'm saying. To like the larger the corporation, the larger the amount of red tape you have to move through to let things kind of ebb and flow, and the world kind of moves like corporations now. So it's kind of like that. I don't know. It's just whatever. We started with C in our introductory course at uni, so it's really a special place in my heart. Thanks for coming in here, Aver. I'm trying my best here. Okay. Cool. That was that one. Let's keep going here. 14. We got 5 more problems, and then we are done with this. I'm not going to do the programming. I've decided to not do the programming projects. There's the exercises at the end of the chapters, and then there's the programming projects at the end of each chapter. I think it's just too much for like the stream content. I do want to make the stream at least somewhat entertaining, even though we are raw learning here. It does have some entertainment value, and frankly for me as well, I do get a little bit bored. Just practicing problem after problem. 18 problems is kind of sufficient for kind of learning the gist of what it is. If we want to go back through and handle these in our free time for fun, we can and tackle them. Or I might just do them off stream for additional practice. But for the stream, I've decided just to kind of keep going with the exercises and then moving on to the next chapter for the reading. But That doesn't mean I won't do these for fun if I feel like it. Okay. 14. Assume that the following array contains a week's worth of hourly temperature readings, with each row containing the reading for one day. Write a statement that uses the search function, see exercise 7, to search the entire temperatures array for the value of 32. So exercise 7 uses the search function. So let's go to our exercise 7 here. Calls const search through an integer n and a number k. Okay, cool. This is really easy. So we would just call the function basically. We have search for temperatures. So this exercise in number 7, if we look, hold on, it takes in an array, an integer and 2 integers, no pointers, no addresses. Okay. So it takes in an array of temperatures. It takes in an integer, 24/7. So we would have like int n is equal to 24 times 7, right? We would put that inside here. We could just do this 24 times 7 here, right? And then we would search for the temperature 32. So is that all this problem is asking for us, is basically just call the function search with temperatures inside the length and the value we're searching for? Assume that the following contains that. Write a statement that uses a search function to search the entire temperatures array for the value 32. Write a statement. Is this that simple? Am I overthinking this? I don't know. I don't think it's that simple. Right? Okay. I think I'm going to move on. Well, what does the search function return? A value? A Boolean. Because we called it here. Right, so it would be like this. Okay, moving on. Chill, I like easy ones like that. Okay, 15. Write a loop that prints all temperature readings stored in row I of temperatures array. Use a pointer to visit each element of the row. Okay, so we have let's just do this in main void. Okay, so what we're going to do is we have an integer array temperatures, which is 24 by 7, 24 hours a day, every hour a day by 7 days a week. So 24 columns. No, oh, 7 columns, right? 7 rows, 7 columns, 24 rows. No, sorry, 7 arrays, 24 columns in the array. Yes, 7 rows, 24 columns. We have 7 days, 24 hours in a day. Okay. What we're going to do is write a loop that prints all temperature readings stored in row I of the temperatures array. Okay. So row equals to, we'll just say I equals to like 5, something like that. We're going to print out the 5th row. So 4 star p, I have a pointer, int star p, which is equal to the dereferencing of temperatures key, right? This is going to be the start we're going to want to go to interesting. So we need to go to the 5th row. We know that there's that many values. So it'd be the total amount minus, okay, so it'd be this. It'd be 27 times 24 less than 5 times 24. That would take us, no, that would take us to the 2nd row. So it would actually be I less than 7. And it'd actually be the absolute value of that. So I know this looks crazy, but am I crazy? So we set the pointer to equal to the temperature's array dereferenced, but we're going to start at an index value, which is the total amount of the array amount, 7 times 24, minus the absolute value of I less than 7 times 24. Right, so this would be, if we're wanting 5, we would need to do minus 2 times 24 and get rid of 2 columns and start off 2 rows ahead, which is the 5th row. No. Yeah. No. The 0th row is the first one. The 5th row is the 4th one. So if we want the 5th one, we need to do 7 minus 3, which is I. 7 minus 5 less than 1. So 7 minus I minus 1. Like that. So if I is 5, we want the 5th row. Right, we need to get the index of 4. So it'd be 7 minus 5, which would be 2, minus 1 would be 4. If we want the 3rd row, the I. So 7 minus 3 is 4, minus 1 would be 3. With 7 rows total, but they're indexed by 0. And with the 5th row, so it'd be 7 minus 5, which would be 2. Maybe it's I minus 7 minus 1. So it'd be like 5 minus 7, which is 2, negative 2, minus 1, negative 3. Absolute value would be 3. We take 7 minus 3 would go to the 4th row. No. 7 minus 5. So 5 minus 7 would be 2. 7 minus 2 would go to the 5th row. So it is the absolute value of I minus 7, like this, times 24. So if we want the 5th row, 5 minus 7 is 2. That would give us 7 minus 5, which 7 minus 2, which gives us the 5th row. If you want the first row, 1 minus 7 is 6. 7 minus 6 is 1. Yeah, I think that this is how you would do it with pointers, right? So if int star p equals the temperature of the maximum of temperatures minus the difference of the row we're wanting, basically, right? P has to be less than So what if we just, maybe we're doing this a little bit too much. Like, what if we just go about it by going, okay, I is equal to 5, the 5th row. We're going to go on dereferencing that value at row 5. What is dereference? So you dereferences and it starts the points there. We would increase it by 5. Oh, okay. So let's not do this, actually. Hold up. Let's do this. So star p is equal to, we need to figure out which row. Start, int start is equal to so start is going to be equal to temperatures, right? We're going to dereference temperatures, right? And we're going to increase by I, right? So this will dereference temperatures, get rid of the outside of array. Now we're pointing to the first array, or the first element in the actual matrix. And then we're going to increase by 5. Well, no, that's going to increase by 5 times. That'll increase by 5 places in that first row. So we need to do 5 times 24. Right, like that. So now if we do int star p equals to the start, right? Or we just have start. Yeah, equals to start. Oh. Right, star p is equal to start. We say p is less than. So what are we going to do here? P has to be less than the amount of values in this row, which is 24 places from start. So start plus 24 P plus plus. Now what we're going to do is read the entire temperature, read each value, right? Prints F to the actual integers at star P. And we say if star P is equal to, oh no, we're just printing one row. So then we can just print F here, \n, and leave it at that. Yeah, I think so. Okay, let's take this, get some feedback. I'm writing a function that, given a specific integer which corresponds to a row in a matrix, it prints the whole row using pointer arithmetic to access the values in that row. I did this by creating a pointer to calculate the starting point, which would be the matrix dereference plus the integer times the amount of columns, which would be the totality of that row. You want to get the difference. No, you would want to get the difference, right? You have temperatures, and we're going up, not 5 times 24 rows. We're not going up 5 rows. So if we have temperatures, which is the start, and that's 0, we're going to add 24 times 5 to that, which would go way into the array, right? 24 times 5 bases into the array. Now, that would kind of visualize this. So that would put us 24, 24, 24, 24, and clear out the entire 5th row. So I think we need to go to I less than 1 times 24. Let's just ask AI to give me an array. Give me a dummy 7 by 24 C array of integers. Okay. Okay, so if we run this is 15. Error, call the undeclared library function printf. Okay. Ah, come on. Yes! Let's go! Nice. Wow, we did it. 1, 2, 3, 4, 5. We even figured out you need to go I less than 1 because by going up I row, the ith row, you would clear out that row that you're wanting to actually print. And so we actually get now the printing of this row here, the 5th row. 1, 2, 3, 4, 5. The ith row is printed. Nice. Good job, you guys. We did that. What's up, Teds? Where are you getting lead code exercises? Yeah, I much prefer this over lead code exercises. I learn way more in this. I'm actually learning a language, let alone just. But I mean, it's different things, right? You're learning algorithms versus language and stuff. Okay. I think I. Let's see, I think I got this one. Yes, that's correct. Temperatures gives you a int star for the first element. I less than 1 times 24 offsets you the start of row I. Since each row is 24 elements wide, multiplying by 24 jumps you exactly to the right row. Yes! Good job, Mike. Wow, there's no way, there's just no way I would have gotten this one, 2 weeks ago, a week ago. So this just shows you that we're learning, we're getting better at pointers. Like we're actually understanding that we're dereferencing a two-dimensional array, leaving us a pointer to the start of the array. We need to go 24 times 24 columns by the amount of rows minus 1 we're wanting. Beautiful. And then setting a pointer to start there. Nice. That is really good. Solid, solid, solid. I'm feeling that gave me a boost of confidence. Okay. Let's keep going. 16. Write a loop that prints the highest temperature in the temperatures array. The body should call the function find largest, passing it one row of the array at a time. Write a loop that prints the highest temperature in the temperatures array. See function 14 for each day of the week. Okay. So what we're going to do is we have int main void. And what we're going to do is we have a temperatures array, which we're going to copy from before. Right? We're going to call, we're going to say for int I, or for row equals to 0, while row is less than the amount of rows, which is 7, row plus plus, and what we're going to do is we are going to call find largest on so find largest takes in a pointer, right? Find middle, find largest, returns a pointer to the largest element in the array. Okay. So,
You're not that guy.
hey,
pal.
thanks so
Trust
much
me.
for the sub.
You're not that guy. Okay.
Appreciate
Yeah,
you so much.
Absolutely.
So find largest takes in a row which will be temperatures key of row so we need to so find largest. We pass in the array, which is the row, so a pointer to the start of the row, right? So a pointer, so we have to pass in a pointer to start of the row. Row. Yeah. So find largest given temperatures key of row column 0. So that's a value though, so we need to, but that's an array. Yeah, that's an array right there. And then we're given a size, which is 24. This would return back to us a int sub largest, a pointer to this value. So int star sub largest. We then say we have int largest is equal to 0. We actually need to find largest on the first row and then move through a 1 forward. So when 1 forward, call int largest is equal to temperatures key of 0. This is going to go through that first row, array. There's 24 values in there. So we have int to find the largest of that. Now we're going 1 row, 1 forward. So we're going to say if the value at star find largest is greater than, no, we'll save it. So we have sub largest is here. If the value at sub largest is greater than largest, then we're going to set largest equal to sub largest. Move on. So int star largest calls find largest here. So if I go to my find largest function here, and let's bring this in. And then let's do include standard.io.h. So we find largest, returns to us the largest address, the address of the largest number. We capture that here for the first row. We then loop 1 forward, capturing sub largest. And then at the end of this, printf to %d, calling for largest. Equals to the value at largest. I will try it, I guess. Warning, comparison between pointer and integer. So sub-largest, okay, yeah, so we need to do largest. $168. Yes! Yes, yes, yes! So what I'm going to do is I'm actually going to put the 168. I'm going to make this 101. I'm going to put 101, 168 here. Let's see if we can try to find it. Make sure that's working. Yes! Let's go. All right, let's take this and let's get some feedback. That's correct and well structured. Clean solution. Find large returns a pointer large element in a single row. Nice. That is good. That is good stuff. Oh, sorry, I missed some chats. My bad. Yeah, it's from Secret Programming: A Modern Approach is the name of the title. I rarely use 2D arrays in C. I want a 2D array. I create a 1D array and access XY with array y times width plus x. Oh, gotcha. You just create like a width boundary because it's in row major order. Yeah, okay, that's interesting. See, or Sonia. So Sonia says that she rarely uses 2D arrays. She just uses a 1D array and uses a width parameter basically to go in between, like for the columns, for the column widths. Sir, are all of your previous classes recorded? I just found your channel. Yeah, everything is on here. Okay, cool. If you guys are liking the stream and are new here, if you guys could subscribe, we're 2 subs away from 5,500. So if you guys want to cross us over that line and be our 5,500th subscriber, now's your chance. Be the man. Okay. Or woman, Sonia, right? Okay, cool. Let's keep going. So that was we're doing really good. I'm actually feeling really, it's crazy. Who would have thought actually just practicing pointers that gets you better at it? Right? Who would have thought? Okay, we got 20 people in here. You guys are awesome. Okay, let's keep going.
You're not that guy.
Hey, there's one.
You're not
Thanks,
that guy.
George.
Okay. Yeah, you? Absolutely.
Absolutely. Okay, 17. Rewrite the following functions. Use pointer arithmetic instead of array subscripting. In other words, eliminate the variables I and j and all uses of the bracket operator. Use a single loop instead of a nested loops. Okay, so we have this function here. Int sum 2-dimensional array, which takes in a const int array and by a length and an int n. Cool. So we have variables, so we're gonna have a sum. We can keep that, but we're gonna use this. So we're gonna say for star p, int star p equals to the dereference of a, right? While a, or sorry, while p is less than A plus the pointer array A, but we're going to dereference A plus plus the size of the matrix. We don't know how many rows there are, though. Oh, we have n. Sorry, n is our thing, so n by length. Right? P++. Okay? So we're going to set our initial pointer to navigate through this two-dimensional array to the start of the first array in A, right? So we're dereferencing the multi-dimensional array to get to the start or the first value, or the first array. We're then going to make P loop through until it is greater than the matrix size, the rows inside times the amount of columns inside total, so the amount of memory spaces in the array itself, the multi-dimensional array. P++. So then what we're going to do is just sum plus equals to star P. And then we can call printf here and just do and say sum, and then put in here sum, right? Oh, shoot. Shoot. Use of undeclared if undeclared length. Okay, that's right. So we need to length. We're gonna have oh, let's go like this. Let's go to our previous problem here. Let's grab this matrix. Probably could make a header file and just import this, but whatever. So we're going to call some two-dimensional array on temperatures, and then a size, which is going to be 7 times 24. Oh, well, we have a length here, which is 24. Length. And then n is going to be 7. So then this is going to return, we're going to call printf. Oh, this returns a value, sorry. Return sum. We're going to call printf and do this to the return of this value. Okay, let's see what happens here. Two-dimensional array. Warning, initializing int pointer with the expression of const int 24 disqualifiers. Okay, so yeah. Call to undeclared identifier printf. Okay, sorry. We're all over the place.
You're not that guy, pal. Trust me.
Hey,
You're not that guy.
5,500.
Okay? Absolutely.
That's what I'm talking about. I like that. Thank you guys so much. We're on our way to 6K. Yeah, that was a fast. We got like we hit 5,000 I think like 2 weeks ago. So 500 in like 2 weeks is pretty dang good. Thank you guys so much for all the subs. I've been streaming a lot more lately, so has been a little bit more because I've been streaming more, getting more content out for you guys. So we built Polyworld live on stream. If you guys are here and haven't checked out our new app, https://polyworld.app. Go ahead and make an account. That's our new project that we built live on stream. Go make an account. Go do some searches for some some betters on there, and let me know what you guys think. Go to site here, Polyworld. This is our site that we built. You can see on the leaderboard. Oh, he still got it. So this guy right here, Oki. Okay, he's been on the leaderboard 19 for 19. He's the only guy left that has a 19 streak for 19 days. Now I think we've had running 20 sweeps total. So he did miss out on the first one, but after the first sweep, he's been picked up every single time, and he has the longest streak so far. So shout out to this guy. Okay, he's got an insane win rate like I've never seen before, but I think his strategy it'll flop soon because I think he just plays like things that are like 95% confident and above. But that one time he plays a contract that 5% hits, he will get wiped out from what I've been seeing. But yeah, an interesting trader here. Interesting trader. So go make an account on polyworld.app. It's the pinned comment, polyworld.app. And make an account, register, and do some searches for some betters. The next refresh is in an hour and 51 minutes. So go check it out. It's great. It's a pretty cool project that we built live on stream here. Okay. Nice. What were we doing? Were we doing something worthwhile in this? I don't think so. I think we've got it though. We were just kind of cleaning things up. Oh yeah, we had some errors. Too many arguments. Some two-dimensional array takes in, just two arguments, sorry. Temperatures and the total length of the array. Yeah, which is not n here. It's n by length. Okay, let's try that. Two-dimensional declared here. Segmentation fault. Segmentation fault. Okay, we're going from the start of the array to the end of the array. What was happening last time we got the segmentation fault? It's because we were accessing pieces of the array. Segmentation fault still. Huh. So let's call a printf here to subsum. And I'll put in sum here. And let's see what happens on these prints. How far does it get? So it's kind of screwing up the entire way. So we increase P forward, dereference P to add to sum. So the star P equals to star A. So we're setting a constant pointer to the start of the multidimensional array, the first row in the 2D array. We are then saying that P cannot go beyond No, we want to dereference. We don't want to dereference the value. We want to dereference A and add to that how many rows So this is going over every value in the array, though, in the two-dimensional array. So A cannot go beyond, or P cannot go beyond the length of the array, which is the amount of columns by the amount of rows, which is n. We're summing the total two-dimensional array. So we need to take the amount of rows by the amount of columns and add that to the start of the array. We're so close to being done. So frustrating. Let's get caught up some chats. All this work in C plus all this works in C++, so he's technically learning C++ too. I think Sonia. It's pretty much the same except for OOP support because he wants to learn C and not all C++ features such as moves, objects, deep variables, smart pointers. Hey, thanks Dyer for the sub. Yeah, textbook is in the stream title. I also have copies and note references in my Discord link down below. Shouldn't n be n and not n times the length? Oh. Yes, sorry, you're right, Sonia, because n is the total length of the entire thing already, exactly. And we're passing n times length into the function here as a parameter. Thanks, Sonia, you're exactly right. So what happened was we're expecting n to be, I'm kind of getting confused on the individual rows versus the multidimensional, right? So n is the total amount of spaces in the multidimensional matrix, not just one row. Length is the size of one row. So it would just be A plus N, A dereference plus N, so just the amount of rows, the start of the multidimensional array plus N, the total amount of spaces, and we feed, so N is N times, 7 times length in this case. So so what I'll say is, I'll say rows here. and instead of N to make it a little bit more readable for me. There we go. So now let's try this. No error. Hey, and we got a sum, and that looks pretty good. Yes. Nice. Let's go, guys. Woo! Bug solvers. We're the bug solvers, the bug catchers. We gotta get one of those like face nets when we have bugs. We'll have to put on like a hat with like a face net and be like, we're bug hunting. Okay, here we go. 18. Last one. Last one. Last one, then I'll probably take a break, and then I'll come back and we'll read chapter 13 tonight. That's what we'll probably do. Because I do want to keep going with the book. I've just been, now that we have some people in here, I want to start the conversation, actually. We have got over 20 people in here. At the very beginning of the stream, we had a little bit of a talk, and I want to actually talk about that again when we have more people here. So, I will be transparent and say, I too have been falling victim lately to a little bit of the AI doomerism. I've been falling, being like, why am I learning this? Like, I'm grinding, and like when AI can just one shot this, and I've been falling victim to watching too many YouTube short doom scroll sessions into about how AI, and every YouTuber now is making videos about how AI this, AI that. There's no more programming tutorials anymore, like Fireship, Theo, Primogen, anybody. Like, it's all gone. Like, they're all doing just AI kind of news coverage, and so it's just like I'm being exposed so much to this like negativity in terms of like, oh, it's going to do this, it's better than you in this way, that it's been really discouraging, honestly. Like, I've just been kind of struggling to be like, even me, so having this proof that we are learning and growing. So I just wanted to ask you guys, that there might be comfort in knowing that other people are feeling this way as well. And it's just kind of having a little bit of like imposter syndrome, honestly, maybe thinking that like, okay, if we have all these tools, we should be like a 10x developer by now, but
You're not
we
that
just
guy, pal,
grind and
trust me.
C for
You're
like
not that
6
guy.
months and
Okay.
still barely scratching the surface.
Absolutely.
And, we have been building full stack apps and fast API and stuff, which has been really fun, but we did have to use AI to help tutor us through those purposes. So like, it's just, I don't know. It's really confusing times. The expectations of speed and learning, and no one has any correct answers, and that's what's really frustrating. So, yeah. Anyways. This book is really good. We used it in my uni course. Oh, thanks. That's good. I'm glad that we have some CS majors in here. It's all propaganda to fund their VC cash burn. Yeah, the Web Dev Simplified. That's the one I watched. His second channel, he showed his analytics, and it was just really shocking about how much. He had some really good points about how the YouTube is just shoving like AI content down your throat, and you can't get away from it. People are building custom tools to filter out YouTube algorithms like suggestions, because it's like you're being kind of like groomed by the content you consume. And it's like, what other content am I going to consume? Like, am I going to go watch like Netflix shows, like just waste my time? No. Like, am I going to go, like, I could read books, but then like like, I'm doing this, but it's a different type of pace, right? So I don't know. It's just annoying. Okay, last problem. Chapter 18, or chapter 12, exercise 18, last problem here. And then we're going to read I'll take a break and we'll read chapter 13 tonight. Okay, this is on pointers and arrays, you guys. This has been we learned a lot. This has actually been really, really good. We've got a lot of practice. Number 18. Write the evaluate position function described in exercise 13 of chapter 9. Use pointer arithmetic, not subscripting, to visit array elements. Use a single loop instead of nested loops. Write the evaluate position function described in exercise 13 of chapter 9. Exercise 13 of chapter 9. This is the one annoying part about the book, is how it references previous chapters' problems, so you got to go back and look at them. But everything builds, so it's whatever. Exercise 13 in chapter 9. Here we go. Okay, here we go. This is it right here. Write the following function, which evaluates a chess position. Given returns an integer, evaluate position, given a character array called board, which is 8 by 8. Board represents a configuration of pieces on chessboard where the letters K, queen, king, queen, rook, bishop, N for knight, I'm assuming, and P represent pawn, represent white pieces, and lowercase represent black pieces. Evaluate position should sum the values of the white pieces. It should also sum the values of the black pieces done in a similar way. The function will return the difference between the two numbers. This value will be the positive if the white has an advantage, and negative if black has an advantage. Okay. So we're going to include standard IO.h header file here. We have a int main void function. And what we're going to do is we're going to write a function called evaluate position, though. Given char board, which is size 8 by 8. Okay. Okay, so what we're going to do is we have white sum black well, we don't really need to do this. We can just take a result is equal to, oops, sorry, all over the place. Int result is equal to 0, right? We're going to have for int star p equals to the first array in board, right? We're going to, while p is less than the total amount of places in board, so it's going to be star board plus 8 by 8. And then we're going to increase p forward. So what we're going to do here is we're going to access the value. So this is actually a pointer to a char, rather. Right? And we actually need, so we're going to need an array of values equals to an array, and what we're going to do is set this to, so queen is 9. Queen is 9, rook is 5, bishop's 3, knight is 3, pawn is 1. What about the other pieces? What about knight? Or what about king? Huh. What about king? I'm assuming king is 10. Maybe king doesn't have any points if it's not given. Okay, so what we can do here is say so we're going to have a char. So we can dereference P, which will be the value. So we'll do a switch on star P for case of we need an ASCII table. ASCII table. There we go. So capital Q. Holy crap, that's small. I can't see anything. Capital Q is 81. So case for 81. We're going to, is it case 81? No. How do you write switch case? I forgot. I always got to look up an example. Oh, so the colon comes after. Okay. So case 81. Do res. So this is for capital, and we know that capital P's are positive. Capitals are positive. So res plus equal by 81 by star P. You break. So for case of what is lowercase or so actually uppercase is above 65. It's to 65 and 90. The thing is you can't do expressions in case statements. So we'd have to do an if statement to capture for uppercase values. So, I mean, it's not super specific. It's kind of a catch-all. Like if someone throws some crappy uppercase value in there that's not Q, whatever. But but the king, right? That's another thing that we don't. The king isn't given a value. So maybe we should keep it like this. So lowercase q is 113. Right, res less equals star p. Because what I was thinking is that we could just say all lowercase less equals all uppercase plus equals, but we don't want to add the king, right? I've been feeling this quite way as a student. Can't make complex system, less dev competition for us to fight against. After my semester ends just a few days away, I think I'll start up a YouTube channel. Any tips to get started? Yeah, honestly, the best tip I can get started is you have to just go in with no expectations I didn't go into the stream thinking anybody would ever watch, and so if anybody ever did, it was just cherry on top. And I just wanted to have capture myself learning and watch it back if I needed to. So yeah, that's kind of where it stemmed from. So just no expectations, no assumptions, just kind of doing it because you want to do it. Hey, thank you, Bruce. Appreciate you. Usually I watch your Python streams. Yes, we've been grinding CEO. Joanne, welcome back. Oh yeah, that's right, Sonia. There's no other piece. The king's value is infinite. If you lose the king, you lose the game. That's why king isn't worth anything. If there's no king, it's gone. That makes sense. Sonia's on the ball today. You can just use the character literal. That's right. So of queen of lowercase q, right? We can just use literal characters. So this would be rook. The thing is we can't do. So maybe I should say, let's do this. Rather than a switch case, we'll say if star p. So I'll say this. Yeah, I'll say star p. So we'll say if star p is equal to quote q or star p. Let me copy this. Star p is equal to quote r, or star p is equal to quote b, or star p is equal to quote p, right? We're going to do res plus equals to the value at star p. Else, if this, but for lowercase values, q, r, bishop, pawn. Do we miss knight? Oh yeah, we did. Knight. You can tell, Sonia, my lack of playing chess. I've never been good at chess. Like I have tried it, and I for some reason I'm just, you know, it just doesn't work for me. And then we can just return, right? We can just return the result at the end of this. So if we have a board, which is 8 by 8, let's ask AI to give us a board. Give us an 8 by 8 array, which represents a chessboard with capitals for Q, R, B, N, P, and lower cases. Make it random for like a random, spot in the game. This is what AI is good for. It's giving us this stuff so we don't have to type it out. Beautiful. Okay, so we have a board here. And we're going to call evaluate position given the board. And then I'm going to call int result is here. Well, we can actually just printf this result. Yeah, I think so. Alrighty. Let's give it a shot. Let's give it a shot. We want to GCC. Ooh, compiled. Oh. Negative 448. That does not seem right. That does not seem right. Crap. Is plus equal to value at the pointer? No, I never. I've heard of Haskell, but I've never seen it at all before. Oh, we're doing this wrong. We're not adding the value of whatever the character is. We are doing. I'm such an idiot. Let me go to my. Hold on. I think what we can do. We have this in. This is chapter 9, exercise. We're not supposed to do the actual value at star p. We're supposed to do the value that corresponds to the map that it gave us here. This would be nice if we had a dictionary to just quickly access values into, but we don't in C, right? So or hash map, we'd have to make our own. But what we can do is I'm just gonna go rip. We can write a case statement for all of these, but I'm not gonna do it. I'm gonna go rip what we already wrote it in the previous problem. Chapter 9, exercise 13. We ripped it here. Here you go. I'll take you. Thank you very much. Welcome in. Okay. Oh. Let's get rid of these. Oh. Whoops, we forgot to bring over the switch on star P. There. Non-void function does not return a value in all control paths. Aha! Boom! Okay, so let's make sure they have a rook. They have 2 rooks, 1 knight, 2 bishops. I don't want to go through this. I think it's 0. Oh, because I didn't get the concept last time. Right? You can see I don't play chess, but Sonia made that apparent, right? The king is not. I made the king 13 points randomly, just for fun. Because I was like, where's the king at? But it makes sense that the king, once he's taken, the game's over, dude. No dirt. All right, there, negative 13. Oh, hold on. This got a king here. So there should be 0 still. Okay, the game is even. Nobody's taking a thing here. Okay, I got you. Everybody has points. Now if I take away a pawn, though, from the black, we should go positive 1. Oh! Let's go. All right, you guys. Whew! Wow. Chapter 18, or chapter 12, that was a lot. Wow, 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 wow. Git add. Finish chapter 12 exercises. All right, the answers to these problems are found on my GitHub, you guys. If you guys would like to check them out and try them out for yourselves and see my answers, highly suggest you do them. Yeah, it is pretty time consuming, but I will say that by working through these problems, figuring out our bugs, going through them, writing the code itself, like it's really like I can feel it's actually learning C. I can feel that in between sessions, like I can go a week between these sessions and remember what we learned last time because we actually wrote it and did it over and over and over again, 18 exercises worth, right? So that's something that's really key is if I just read the chapter and then came back into the next chapter and then to the next chapter, I wouldn't remember any of this. Like it's just too much information. It's too dense. You have to practice, you have to implement it, or it's just unless you have some sort of, top tier memory or whatever, right? It's kind of beside the point, but I I really think that like the sitting in this chair attempting hour after hour is solidifying it because I was worried that I wasn't going to remember a lot of stuff, but I am remembering things like when I come to sit down and put my mind to it, I don't we didn't have to go back through and read stuff out of the chapter again. Like we were able to solve all these problems today, um, off of our memory, which is really cool. All right, you guys. Thanks so much for joining me for today. This was a 3-hour session where we finished up the back half of the chapter 12 exercises. I will preface, remember guys, we made a mistake and we did complete exercises 1 through 4 in chapter 13. We were on the wrong chapter when we started this. So we actually have a little bit of an easier next chapter. We already kind of started it. But we completed 4 exercises. We never even read the chapter. So, hey, we're pretty good, I guess, huh? So we're gonna come back. I'm gonna come back later this evening, probably in 3 or 4 hours or so. And I'll read chapter 13. Oh, this is chapter. I was worried here. I thought we were doing. I was like, oh my gosh, please tell me we didn't do chapter 10 exercises. No, we were referencing an old exercise. So chapter 13 is on strings. So 13 is on strings. It starts off on page 277 and goes to, oh god, oh god, oh god, 305. Oh my. 311. 30-page chapter? Oh my gosh. Bruh. We might have to do 2 chunks maybe. Dang. 30-page chapter on strings. We're cooked. How many chapters are there? Let's see. Can we how do I show the sidebar? What the heck? $24, $25. my gosh, 27. We're cooked. All right. On table of contents. That's right. So we are on strings on 13, 277 through 315. Processor. Ooh, here we go. This is going to be a good one. The processor. That's where we'll learn a lot of stuff. Oh, look how long this chapter is, though. Wow. Cooked on that one. Writing large programs. Structures, unions, and enumerators. Advanced uses of pointers. Declarations, program design. So it seems like we kind of need to get to, like, it's just really in depth. Like, we can get to kind of chapter 20 and then start kind of building stuff. After that, it's pretty, like, additional C99 support for mathematics, miscellaneous functions, international features, error handling. So it's kind of like, it seems like maybe chapter 22 or 23 is kind of where it kind of starts to wrap up. All right, you guys. This is very inspiring. Yeah, we're literally raw dogging this, man. Exactly. All right, you guys. Thanks so much for being here and hanging out with me. We did a good 3 hours. I'll come back and we'll start the reading of chapter 13 on strings. This is K.N. King C Programming: A Modern Approach, second edition. We'll come back and start on chapter 13 in a few hours. So thanks so much for being here. I'm going to take a little break, grab some food, and probably walk the dog. So see you guys in a little bit. Make sure you guys subscribe and join the Polyworld project. We have our recent project we built live on stream, Polyworld. Make sure you guys go make an account. Look at our leaderboards. Look at all the accounts on there. Do some better searches. If you have an account, you can do a better search, and it's pretty cool. So go check out our project. Thanks so much for being here, and I'll see you guys in a couple hours. Peace out.